Welcome everyone to this virtual tour of ESO, ESO's Paranal Observatory. My name is Hector Salas and I'm going to be your guide today, alongside with Farid Char, who is going to be our producer. So I'm a PhD student at the Leibniz Institute for Astrophysics in Germany, located specifically in Potsdam, and I work mainly with topics related to the circumgalactic medium, that is the environment that immediately surrounds galaxies. I have been a member of the team of guides for Paranal Observatory since 2019. I started while I was doing my master's at Universidad de Antofagasta. Today I'm joined by Farid, who is going to be our producer. Farid, how are you? Farid, can you hear me?
Hello, Hector. Nice to meet you. Yes, yes. Can you hear me?
Yeah, I can hear you. Yeah, so
Can you hear me
can
now?
you?
Okay.
Yeah,
Yeah. Well, nice to meet you. Yeah. Well, from my side, I will be the producer for this virtual experience, and I have been working for as one of the tourist guides for Paranal Observatory for more than 10 years, and I have also many years of experience in astronomy outreach and education. And one of my personal hobbies is astrophotography. So today I will be in charge of receiving your questions or comments. So later we can answer to your questions during all this streaming. Okay, so please you can use the comment section in Facebook or YouTube, and we are going to answer your questions later. Okay, Hector, so we can go ahead with this virtual experience. Thank you.
okay, thank you. So ESO would like you to accompany you on these virtual tours, taking astronomy directly to your home or wherever you are. And we're going to start by telling you a little bit about ESO, the European Southern Observatory. This is a non-governmental international organization comprised by 16 member states, and we will see a picture on the screen with all the different countries that belong to this at some point. There we have it. So we have several European countries. We have Denmark, the Netherlands, United Kingdom, Ireland, Belgium, France, Portugal, Spain, Sweden, Finland, Germany, Poland, Czech Republic, Austria, Switzerland, and Italy. The headquarters of ESO are located in Germany, in Garching, near Munich, actually. And we also see two non-European countries in that picture. We have Australia, who joined a couple of years ago as a strategic partner. And we also have Chile, and Chile is the host country. The observatories that ESO controls are all built in Chile. During the 60s, ESO was looking for the best places to build astronomical observatories in the southern hemisphere. And at the same time, Chile was trying to attract foreign interest to the country to have better human capital, let's say. And so ESO was looking at one of the best places on Earth to do observations from the ground, the Atacama Desert in Chile. ESO has three different observation sites in Chile, and we will show them in a picture at some point. Now, the mission of ESO is to design, build, and operate astronomical observatories. What for? Well, to enable important scientific discoveries and foster cooperation in the field of astronomy. And now we can see on our screens the different observational facilities of ESO in Chile. So for starters, we have La Silla Observatory. That was the first observatory of ESO in Chile, built in the 60s. Their main telescopes there are the ESO 3.6 meter telescope, or 360 centimeters, that is the diameter of the mirror, and the NTT, the New Technology Telescope. Now, the 3.6 meter telescope has a dedicated instrument called HARPS that is specifically designed to find planets that are orbiting other stars. These are called exoplanets. So this is an exoplanet hunter. And this is more to the north of the country. We have two different sites. We have Chinantor, and in Chinantor we have ALMA and APEX. So these are antennas. And in the case of ALMA, this is not just ESO. This is ESO plus some the US and other countries from Asia Pacific. So ESO is one of the many collaborators in the ALMA site. And in the same region of Chile, or to the coast, we have Paranal and Armazones. So Paranal Observatory is the site that we're going to see today. And there we have the VLT, the Very Large Telescope. Also, we have the VLTI, which is an interferometry array to use with the VLT. And we have some survey telescope, VST and VISTA. Now, very close to Paranal Mountain is Cerro Armazones. And in Cerro Armazones is being built the ELT, the Extremely Large Telescope. That is going to be the largest ground-based telescope with a diameter of 49 meters. Now, between the area of the ELT and Paranal Observatory, which are very close, there is being built the CTS South. This is an array of telescopes focused on detecting gamma rays. So this gives us a bit of an idea of the different places that ESO have to observe in Chile. And we're going to go now virtually to Paranal Observatory. So we're going to travel with the power of this virtual tour through the Atacama Desert in Chile. So, okay, we jump to the Paranal Observatory, and here we can see the top. Now we're on the desert. So we're walking through the desert of Atacama, the driest desert on the planet, and we're heading toward Paranal Mountain. We can see it there in the distance. Uh, the summit of Paranal Mountain is 2,600 meters above sea level, and these mountains belong to what is called the coastal mountain range of Chile. Now, this mountain is located only 12 kilometers away in a straight line of the ocean. So you may be wondering, can we see the ocean in this video? Well, we see some hazy clouds in the background, and the ocean is located right underneath those clouds. So why do we have those clouds there in a place where we are building, or where we built an astronomical observatory? Well, those clouds are there because of the influence of the so-called Humboldt current. This is a current, a mass of very cold water that comes from Antarctic and goes through the coast of Chile and Peru, and it produces an effect known as thermal inversion. And what this does is that all the humid and cold air that is very bad for astronomical observations, it stays put at about 1,000 meters above the sea level and doesn't go any higher. And since we have here the coastal mountain range of Chile, with mountains that go over the 2,000 meters, this air doesn't go farther inland. We also have another uh, natural barrier here that helps us to have this excellent place for astronomical observations from Earth, the Andes. So at about 200 kilometers in the opposite direction towards the east, the Andes mountain range, towering over 6,000 meters high, is stopping the clouds and bad airs coming from Argentina and Bolivia. And the result is this very dry desert, the driest desert on the planet. And an ideal place for astronomical observations from Earth. The air here is very clear and calm, and we have an average of over 300 clear nights per year. So now we're going to move closer to the observatory. And in the meantime, I can tell you that the name Paranal is a word from the Quechua language, and in that language it means whirlwind, which could be a reference to the whirlwind that sometimes forms in the desert because of the wind. But usually the air here is very calm. Now here we can see again the summit of Paranal Observatory, and we can see the different telescopes and their name, and we see that this is not an ordinary mountain, and we have a lot of very large telescopes there. So now we're going to go and step on the summit of the mountain and look around to see what we can find. So if we can switch to the main platform of the observatory. So first we're just gonna take a look around. We can see some very big telescopes and a few smaller ones. And as we're turning, we're allowed looking toward the west. We can see some sea of clouds in the distance, and below those clouds is the Pacific Ocean. And we can keep rotating our view. Now we're looking towards the south, and we can see a very beautiful desert landscape. Over here is the main campment of the observatory. Now we're looking towards the east, and we can see the Andes in the distance. And over here we can see this arrow marking the place of the Yaco volcano, and this is actually the border with Argentina. And over here we can see Amazonas, the site of the ELT. So now that we're back, we can tell you a little bit about the PLT, the Very Large Telescope. And the first thing to notice is that the PLT is not a single telescope. It's an array of 4 very large telescopes that we can see here. So we have UT1, UT2, UT3, and UT4, where UT stands for Unit Telescope. Each of them has a primary mirror that is 8.2 meters in diameter. They are among the largest mirrors ever built. Now they can work together, observing the same object on the sky, or they can work independently, observing different things. And each one of them has space for 3 different instruments, or 3 cameras if you want. Now, in addition to the 4 very large telescopes, we also have this smaller one. These are the auxiliary telescopes. They have a primary mirror that is 1.8 meters in diameter. So about a tall person, let's say. There are 4 of them. So we have one here, we have a second one over here, a third one, and a fourth one. And as you can see, they're on top of tracks, and that is because they can be moved. So why do we need telescopes that can be moved? Well, that is because the auxiliary telescopes, they only work together doing what we call interferometry. And we have a small video to talk about the interferometry. So when we're doing interferometry, what we're doing, we're observing the same object in the sky with different telescopes. So why is important that the telescope can be moved? Well, for interferometry, the baseline is important, and the baseline is the maximum separation between the telescopes. So if we could put the interferometry video, Farid, there you go. So when we're using these telescopes, we can simulate a virtual mirror that is up to 200 meters in diameter when we're combining all the telescopes. And the point of doing interferometry is that it allows us to have a better resolution. So the resolution is dependent on the separation of the telescopes. So that's why it's important to move them, so we can adjust the resolution a bit. And when we're combining the lights here, this is not a post-processing that we do it in a computer combining the images. No, this is fully analog. The light of the different telescopes goes through tunnels, the underground tunnels, being reflected by mirrors, up to the central building that is the interferometry building. And then the light is combined. And as I mentioned before, this allows us to have better resolution. But what does this mean? This is our ability to separate things in the sky. With low resolution, 2 stars that are very close together might look like a single star. With high resolution, we can see them as different objects. So that was the point of interferometry. So if we can use the interferometry technique, what do we also need to have very big telescope like the UTs over here? Well, that is because if we want to see fainter objects, we need to collect a larger amount of light. And with interferometry, we don't really solve that problem. So if we want to collect more light, we really need to have larger mirrors. This is like putting a bucket on terrain. The larger your bucket, a greater amount of water that you can collect. The larger your mirror, a larger amount of light that you can receive. And this allows you to see fainter objects, and they could be either intrinsically fainter or they can just be much farther away and therefore look fainter to us. Okay, so with that in mind, I will mention you that the big telescope, they also have names in the Mapudungun language. This is the language of the Mapuche people, the natives from the central and southern parts of Chile and also Argentina. And in that language we have Antu for UT1, Antu means the sun. For UT2 we have Cueyen, which means the moon. Then for UT3 we have Melipal, and Melipal means something like 4 stars, and is a reference to the Southern Cross constellation. And finally, for UT4 we have Jepun, and Jepun means something like the star, and it's a reference to the planet Venus that is very bright in the evening or in before sunrise, depending on where it's on his orbit. Now, because of time, we don't have enough time to visit all the 4 big telescopes, but they are exactly identical on the inside, with the only difference that they have different instruments. I already mentioned they have a space for 3 different instruments, and there are difference among the 4 big telescopes. So we're only going to go inside of one of them, and we're going to go to UT3 or Melipal. So here we're inside the telescope, and this is very big. We have some people here on the image that during the day they're doing some maintenance, and this gives us an idea of how big this thing is. As I told you before, the main mirror is of 8.2 meters in diameter, made out of a single piece. This is a monolithic mirror. We have larger telescopes are being built right now, but they use segmented mirrors. This is just a single piece. And this mirror is made out of a special material called Cerodur, that is a mix of glass and ceramic. And while it's 8.2 meters in diameter, it's only 17 centimeters in thickness. Now, the layer that gives the reflectivity is a very thin layer of aluminum, and I'm talking about nanometers, so thinner than a human hair. Now, this is the main mirror. On top, we have the secondary mirror. So the primary mirror, the main mirror, is a concave mirror. Then the secondary, that here on top is a convex mirror. And there is a third mirror that we cannot see very well in this image, but it's on the center here. Now, the primary mirror plus this wide supporting structure weighs 22 tons. This is very heavy. And we're going to go down. So now we're below the mirror. And here we can see the white cell that supports the mirror. And we can see that we have these little gray boxes over here. These are the actuators. Okay, so the mirror is very heavy. And it's not a normal mirror, it's a special mirror. So it's not like the mirror that you have in your house. If the mirror were done the same way to the type of mirror that one has in his bedroom, for instance, when you tilt the telescope to observe different positions of the sky, the weight of the mirror will be too much and the stress will be too high, and therefore it could break. So the solution was to use this special material called Cerodur that has a certain flexibility, so the mirror doesn't break, it bends a little bit. But that is also a problem, because if we want to have always the same high quality of observations, the curve of the mirror has to be the same always. And here's where the actuators came from. So these little boxes, they're like pistons. They can push or they can pull. So we're actively measuring the curve of the mirror and correcting it. Hence the name active optics. And this is one of the technologies that make this observatory one of the most advanced in the world. Now, we're going to go back up. And you may be wondering, how does this work at night? How do we do to observe? Well, first off, we need to open the enclosure, and we can follow this part over here. This is sort of like an L shape. That's the door that opens to the sides. And then we can let the light come from the sky. And this telescope has 2 motions. So the blue part that is right here, that is the mount of the telescope, and that is fixed. this white part can be tilted while being on that monitor. That's one motion. And the other one is that this part of the sky, of this floor, that is separated from the rest, can rotate in 360 degrees. So combining the rotation with the inclination, we can point at different points of the sky. And we have a small animation to show what happens at night when we open the enclosure and the path that the lights follow when we are using the telescope. So if we can put that video. While we wait for the video, I would like to remind everybody that you can send us your questions or comments and we will answer it at some point during the tour. And I'm going to put the video right now. We have it. So this is obviously exaggerated. The enclosure doesn't really float on air, but it gives us an idea that it's open to let the lights pass. And the light is going to come from the sky, from a star or a galaxy or a planet, whatever we're observing, going to hit the primary mirror, bounce, and since the primary mirror is concave, it's going to focus it on the secondary mirror, which is convex. The primary is concave. And then it's bounced to the third mirror. And the third mirror can send it to the right, to the red box, to the left, to the blue box, or just let it go straight down. That's the way we can select which instrument we're going to use. So in this animation, the instruments were displayed as boxes. So here we have one of the instruments, PIMOS. The other one is on the other side, and the third one is below over here. In this case, it's called Symphony. So those are the three instruments that this telescope have. Now, at night, there cannot be anybody in here because all the lights have to be turned off and people are, there cannot be anything that disrupts the observations. So during the day, people do the maintenance, but at night, the astronomers, they are working from the control room at a completely different building. And that is going to be our next stop on the tour. But before we go, maybe we have some time to answer a few questions. Uh, do we have any comments or questions? Uh, I don't see any questions. I see a couple of greetings. So we have some greetings from Sway Graven, who sent us love from Amsterdam. And we have greetings from Jose Maria, who's both Sway and Jose are regulars on this tour, so it's nice to see them again here.
Hector,
Yes?
can you hear me now?
Yeah, I can hear you.
Yeah, sorry, have some disconnection. So yeah, well, as you saw before, we have no questions so far. I don't know, Hector, if you maybe already explained about the maintenance of the mirrors.
No, I haven't talked about that. And this is one of the usual questions that we have. What kind of maintenance we need to do on the mirrors? And there are two different type of maintenance that are normally done. So for the first one, uh, an engineer or someone will use this lift over here, and we will tilt the mirror, and this person will spray it with a foam of carbon dioxide. And the idea is that the foam that will go down because of gravity, and it will drag with it any dust particles that might have landed on the surface of the mirror. That is one of the ways of cleaning the mirror, and this is done every other week or so. It's a fairly simple process. There is a much more complicated process that is the recoating of the mirror. As I mentioned, the layer that gives the reflectivity is a very thin layer of aluminum. So what we do is we take the entire mirror out, and to do that, we help ourselves with this forklift that we have over here. Then the entire mirror plus this white supporting structure is taken towards the base camp, and then in a special chamber, the aluminum layer is removed, and then a new layer is put on the mirror. So since you have a completely new layer of aluminum, it assesses the mirror to be brand new. Now this entire process that is very delicate, we need to make sure that we don't break the mirror at any points because there are no replacements for these mirrors, and the mold that was used to build them is no longer exists. So everything needs to be very carefully done. Now, this whole process takes about a whole week, and during that week, there is no mirror on the telescope, so you cannot observe with that telescope. And this is done every 18 months in sequence. So we start with UT1, 18 months later is for UT2, and so on and so on. So those are the two ways to maintenance on the mirrors. Now we have a question here from Barbara Lloyd. What is the best time of the year to visit? Also, do you have many people asking to check a specific part of the sky? Okay, the best time of the year to visit, I will say maybe on spring. Summer could also be a nice time to visit. But, well, first to mention, you can come in person to Paranal Observatory and visit it in a completely free way. We have open visits every Saturday, one at 10 a.m. and one at 2 p.m. And these are completely free, but you need to register yourself on a website before. We also have visits for the Sea Observatory as well. Now, I'm saying spring and summer because, well, in summer it's a bit too hot, but if you like the heat, then it's fine. And in during the winter, where the nights are a bit longer, maybe it's not the best time to visit, but there are open visits the whole year round. And do you have any people asking to check a specific part of the sky? Well, not really. I mean, depends on what you want to do. So, from a point of view of the astronomical science, in some cases it makes sense to observe the same parts of the sky. Like you might be familiar with the Hubble Deep Field and the Hubble Ultra Deep Field later on. So just to quickly point it out, with the Hubble telescope, at some point someone decided to observe for a very long time a part of the sky that looked to be empty. And we observed there and we found a bunch of very distant galaxies. And then the same part was observed again with the Hubble for a longer time, and then with MUSE, that is an instrument here at the UT3. And that part of the sky has been observed with many different telescopes. So since you have a lot of data for that part of the sky, it makes sense to get more complementary data to observe all the different galaxies that we know were there. I hope that might answer a bit your questions. Now, uh, we're going to continue
Oh,
to the control room, and we have Farid back. He's been having a bit of internet problems.
yeah, sorry, Hector, I am back
It's fine.
here.
So now we're going to head towards the control room, but we're going to have a second time to answer more questions and more comments. So keep sending all your questions that you might have. And Farid, if you can, maybe you can put the link to the visits web by
Yes.
for the visits on the chat because people already ask about that. Okay, so we're going to head
Oh,
to the control building and this one over here.
excuse me, can you repeat, please?
Yeah, so
Can you repeat, please?
yeah, if you can put the link for the visits to the observatory so people can check the information and where to register in case they want to travel to Chile and go to visit Paranal. Okay, so we are seeing the control building from the sides. And in addition to the control rooms, there also here are offices for the engineers and people for logistics and whatnot. And here we are inside the control room. Now, this is divided into different sections that control different telescopes. So over here we can see a small sign that says UT4. And that is because this part over here controls the UT4 telescope, also known as Jepun. On the other side, we have over here for UT3 or Melipal, the telescope that we were just visiting. If we advance, we can find the area for the UT1 and for UT2. And we're going to stay here while we explain a few things. So you might be wondering how many people work here at night. You can see that there are a lot of chairs, a lot of screens, a lot of computers. So how many people are actually needed here at night during a normal observation run? Well, usually there are going to be only two persons here. There's going to be an astronomer and a telescope operator. So these telescopes, they are very expensive and very high technological. There is a job that is just to control and handle the telescopes. They don't trust the astronomers to do that. So, and that's the job of the telescope operator. So you can think of this as a pilot and a co-pilot in a plane or in a rally car. So the telescope operator, he's the pilot. He's controlling the machine, he's moving the things, he's in charge of the operation of the telescope. The astronomer, he's the co-pilot, he supervises the observations, he's in charge of the science. He has the route that we're going to follow through the night for our observations. So if we're only two people here at night, well, why so many screens? Why so many computers? Well, you have to remember, in addition to control and move the telescope, we also have three different instruments attached to the telescope. So we can have dedicated computers to each one of them. We also need to have information on the weather conditions. So we have a screens displaying just that. If the weather conditions are bad, if there is too much wind or if there are clouds or something that almost never happened at Paranal, the possibility of rain, then we might need to close and stop observing for the night. So we must always be mindful of the weather conditions. Now, who can use this? Who can observe here? Well, astronomers of every country in the world can use these telescopes, but they need to apply for it. So there are 2 times a year where astronomers have to apply to get telescope time. And these times are usually very stressful for astronomers because they need to send very detailed observation proposals. They need to say not only what they want to observe and what are the scientific reasons to observe that object, but also with which telescope, with which instruments, how many hours of observation would be minimum to get the science done, how far away do we need to have the moon so it doesn't disrupt the observations, has these objects been already observed with other telescopes, and what data is already available, so on and so on. And then a committee will decide to who they give time. And this decision is based solely on the scientific merit of each proposal. And this is highly competitive. Uh, it could be, we could receive on average something like 7 times more proposals than the actual observation time that we can assign during the year. And for some instruments, it's even more competitive. For the Muse instruments in TUT4 is very competitive, for example. Now, if you send your proposal and you did a good one and got accepted, what happens then? Well, you can travel here and be sitting here on the chair and supervise the scientific observation, but that is use the travel mode. There is also a service mode in which you do not get to travel, but you give you instructions to an astronomer of the observatory staff, and they do the observations for you. Most of the observations done here are through the service mode at about 70%. Now, once you have your observations, they are private for the astronomers that submit the proposal for about 1 year. After that, everything is made free. Anyone can create an account on the ESO website and request the data. But astronomy is a very collaborative science. So what you're usually going to do is maybe you will send an email to the person that take some data that you might want to use and tell them I'm trying to do this with this data. Is that okay with you? And they will usually agree. Maybe they even ask to collaborate with you. Okay, so that gives us an idea of the way that astronomers have to do to be able to observe here. But what are the scientific results of this? And to show this, we have a small video showing the top 10 scientific discoveries made not only with Paranal Observatory, but with all the observatory of ESO. So if we can put the video.
Observations with ESO telescopes have led to many breakthroughs in astronomy and, over the years, have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it, stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history, elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at Lucia was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when two independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone.
Okay, that was the top 10 scientific discoveries made with ESO's observatories, but we have one extra, a bit of a bonus track relating to a black hole. And so let's see if we can. So, the Event Horizon Telescope, EST, an array of 8 ground-based telescopes distributed throughout the planet, coordinated by an international collaboration, achieved the first direct visual evidence of a supermassive black hole and its shadow. The image reveals the black hole at the center of Messier 87, a massive galaxy in the nearby Virgo galaxy cluster. This black hole is 55 million light-years from Earth and has a mass of 6.5 billion times that of the Sun. You have the picture there on our screen. Very impressive. And time to continue with our tour. We go back to the main platform, and now we're going to show you something that we can only show you through this virtual tour. The view from the main platform of the observatory at night. Yeah, the in-person visits, they cannot be here at night because people are working during the observation nights. So no one is allowed to be here. But we can see this through the magic of this virtual tour. So we're going to show you a couple of things on the sky. And let's start by the constellation of Orion, one of the most recognizable constellations, visible both from the northern and southern hemispheres. So we have here Orion the Hunter. We have here Betelgeuse, the red giant, that is supposed to explode as a supernova in the next hundreds of years or so. Nobody knows when. And in the past has been changing its brightness, giving news, people thinking something might happen, but so far nothing yet. We also have over here Orion's Belt, or as it is known in Chile and other Latin American countries, Las Tres Marías, the Three Marys. In the mythology, Orion was a hunter. He was the best hunter of his time. And in the version of the story that I know, he tried to hunt a deer that was sacred to Artemis, the goddess of hunters. And she didn't take that very well. So she ended up putting Orion on the sky alongside all the different animals that he has hunted. So he will have to fight with them for all eternity. So here we have the hunter, and over here we have the sword of Orion, and here is the Orion's Nebula. That is a stellar formation area. Very close to Orion, we have the Canis Majoris, one of the hunting dogs of Orion. And we have here Sirius. This is the brightest star in the night sky. As we go down a bit, You can see over here Taurus, the bull. And we have here Aldebaran, the brightest star of Taurus, and these are the horns of the bull. And here close to the horizon we can see the Pleiades, an open star cluster, a very beautiful object to watch and a favorite of many amateur astronomers. And we can see that we also have a bit of light here from the sunset. It's still not completely dark, and yet we still have this amazing view of the sky. Now, let's watch some things that are only visible from the southern hemisphere. So if we turn around and look towards the south, well, for once, we can see these things over here, these sort of cloudy features. These are the so-called Magellanic Clouds. These are satellite galaxies of our Milky Way, and they were named after Ferdinand of Magallanes in his circumnavigation trip around the Earth. He's the first ones to describe them or to leave a written registry of them. And you can use them to find the southern direction. In the northern hemisphere, we have a very bright polar star that we can use to find the north, but we don't have that here in the southern hemisphere. So what we can do is we can take the Magellanic Clouds and build an equilateral triangle. So in the missing point of the triangle, I will have to go towards the Milky Way, not towards the other direction. That is the southern celestial pole. There is a second method to try to find this southern celestial pole using the Southern Cross, the smallest of all constellations that we have over here. And what we do is we take the larger stick of the cross and we extend it 1, 2, 3, 2.5, some people say 4 times, and we get to the southern celestial pole. And if we go to the south, to the ground, then we have the southern direction. And we're going to finish this view of the night sky. Well, over here we have our Milky Way, or galaxy, our home in this vast space, and we're going to mention uh, some of the cosmovision that the natives of this area used to have. And for them, the Milky Way was a river, and different animals will come to this river to drink water. And for example, over here, we have a llama. So this is the neck of the llama, then we have the mouth, that is the nose, we have an eye over here, this bright star, then we have the 2 ears, and then the neck. And depending on the time of the year, we can also see part of the body of the llama. We also have some birds and some other ones. And with that, we are going to go back to the day, and we're going to go to our last stop on this virtual tour, the base camp. So we're going to go down. We're at 2,600 meters above sea level. Now we're about 2,400 meters. And the base camp of the observatory is a mini city in itself. We have everything we need to have the observatory running here. We have some workshops, we have some medical center, we have places for people to live, we have a gym, we have a bit of everything. And we're going to head towards the residencia, the so-called hotel of the observatory. This is where astronomers stay while they are working here. People work here by shifts, so they stay several nights here. And this looks like it's going underground, but the building is actually using the shape of the mountain. And before we go inside, let's take a look around and see this desert landscape. Very beautiful, but it could get a bit monotonous. But if we go inside, we have something completely different. We have a tropical garden that is aided in part because of this pool over here. And this pool is not just so people can do exercise in their spare time. This pool plus the garden, they are here to increase the humidity inside of this building because this is a very dry desert and the dryness is not too good on your skin. So have an astronaut too good to breathe all the time. So have a higher humidity inside here is a nice thing to have. Over here at the center we have a curtain, in case you're wondering what this is. And this curtain extends at night. And the idea here is to prevent the lights from the inside of this building to go outside. so they don't disturb the scientific observations. Now, in this building, we have over here the cafeteria. There is a library, a music room, a game room. There are some office. This is the reception, and the rooms are over here. And with this, time to make a stop and see if we have some final questions before we say our goodbyes.
Hello, Hector. Can you hear me?
Yeah.
Yeah. Okay. Yeah. So during this time, we have had some additional comments from the people in this streaming.
Mhm.
Well, for example, I can see here Mario the Growth is asking, what do you think about dark matter and dark energy? Do you think will it be solved in the next decade or so?
Uh, Dark matter is probably the easier of those two problems. So dark matter is basically matter we cannot see. We know for gravity from the orbits of different stars and galaxies that there should be more mass. So the question is, what is this missing mass that we're not seeing? And it could be anything. In principle, it could be planets, asteroids, black holes, but it could also be something more exotic like WIMPs, weakly interacting massive particles. And from time to time, there are some advances of this. It's a complicated problem, but there's always the possibility that there's just you don't have the enough capability to see everything that there is there. So as with the ELT when it's finished, maybe we can see some additional objects that we cannot see right now. Who knows? Dark energy is way more complicated. That's related to the expansion of the universe and that being accelerated. And we have no idea when that might be solved. There are some alternatives like modifications of gravity that people have proposed. That is one of the greatest scientific questions that we have right now, and who knows when it will be solved.
Okay. Thank you, Hector. We have another question here from Marina Sesco. She is asking, are there some Italian astronomers in this period, or in general in Paran?
In general, the people working at the observatory are very international in some ways. I have I have no idea if there are any Italians right now, but back then when I was still in Chile and used to go to the in-person tours in the observatory, I definitely hear some Italian accents at the cafeteria. And Italy is a country that is part of ESO, and I know Italian astronomers that work with data taken at Paranal, so definitely is some Italian presence, and also from other European countries as well.
Okay, thank you, Hector. We have a question here from Jose Maria. He's asking on the network. I think he's asking about the video of the top 10 discoveries.
Okay,
They are talking about something called the Hills Cloud. He's asking if that exists. They say it belongs to the solar system.
okay. So
And this, yeah,
mhm.
yeah, Hector.
I was I haven't heard of these hills clouds before, so I did a quick look for them, and what I found out is this is a theoretically proposed part of the solar system. So maybe some of you are already familiar with the Oort cloud. So this is usually mentioned as a reservoir from where comets come from. So it's material that is farther than Pluto. So the idea of this hill cloud is somewhere that is more inside of the solar system, and this was proposed to explain some of the observed motions in the Oort clouds. So they will be sort of similar like the Oort cloud, but after Neptune. I haven't found anything that prove that this exists, but it's plausible. Um, so it's a proposed idea. It might exist. It might not. So far, it has not been proved to exist, but there's nothing that says that it shouldn't exist.
Okay, thank you, Hector. Here we have a question from Songli. He's asking, how about internships? Do you accept internships in?
Yes, ESO accepts internships of many different kinds. Um, I did one when I was as a let's say professional astronomer. I'm still doing my PhD, but I did one as an astronomy student. I did it at Chile at the headquarters that ESO had in Chile at Vitacura. But these are not limited just to people who study astronomy. There are also internships from engineers, also for I've seen some from journalists working in um, outreach. But I also seen announcement for high school students for some like very quick projects. So there are internships. Uh, they are either usually either in Chile in Santiago, where it at the headquarters in Vitacura, or in Europe in Germany in Garching, where the headquarters in Europe are. There might be some that can be done remotely. I don't know. The one that I did was remotely because of COVID, not because it was designed to be remotely. So there are. I'm going to try to find the link to internship at least, so maybe put it on the comments. But for now, let's just say that there are some internships.
Okay,
Do we have
thank you
any
very
other
much,
question?
Hector. I think we are running out of time. So, for example, here we have an interesting comment from Songlis. He says that the night view is spectacular when you was showing the night view from Paranal. And he also say as expected of a place with low light pollution. So maybe just to summarize, maybe you can mention something about the importance of light pollution in general for an observatory.
Yeah. This is highly important and it's something that we had actually been worried about in the case of Paranal Observatory because there are plans to build a facility very close to the observatory. Well, not very close, but close enough that the pollution is going to be a problem. Um, and these facilities, I don't remember exactly how far away from the observatory is supposed to be. I think it was something like 30 kilometers or something like that. But it was already estimated that the amount of light pollution that could have will significantly affect the observatory. So there have been some workings with the Chilean government to prevent this, to find a better place for this facility to be built, and also to improve the laws that are regulating the light around the observatories. So there was an unanimously approved change in this law that is intended to secure a given radius around the areas of interest. But yes, this is very important. These skies are unique and they're a treasure not just for Chile but for the whole humanity. And they can affect a lot. Like in the case of the Sea Observatory, from the observatory you can see the lights from the road that is very far away, in my opinion. And you can see that that's already affected a bit. And well, not just lights from cities, but we also have the problem with the constellation of satellites, like Starlink. That is also something that is worrisome for astronomers. So
Okay,
yeah, it's a
thank you very much.
very delicate topic,
Yeah,
and there are
yeah,
efforts to
uh,
protect the skies as much as we can.
yeah. That's right. Uh, well, thank you very much, Hector, for your answer. And as I said before, we are running out of time, so I'm sorry because we cannot cover all your questions. But of course, we have other tours in other opportunities, so maybe you can join us in another opportunity. So I think, Hector, we are in conditions to going to finish this experience. And by the way, I already include the link for the visits to Paranal.
Mhm. Yeah, and I put the link from the recruitment portal of ESO where you find information about job openings as well as the internships and things like that. And finally, we are doing the spiritual tours Every Saturdays, we are switching between Spanish and English, between Paranal Observatory and the Sea Observatory. So if you want to join for the next time, or you know somebody that might be interested, please let them know and keep an eye on our social networks to know what the next tour is going to be about. And with that, I will say goodbye. It was my pleasure to be your guide today, and see you next time.
Hey, see you. Bye bye.